All right, hello everybody. This is me in my classroom, and I'm trying to demonstrate and explain how you will be expected to understand and do the Newton's second law lab. Now, ideally, obviously, we would have you in the classroom yourselves with all of this equipment, doing this yourselves, but we can't do that now, so we have to do it virtually like this. So hopefully this will all go according to plan. I'm not the world's greatest videographer, so you'll see how this goes. But let me familiarize you with, a little bit with the equipment. So we've got a dynamics track that's very smooth and very low friction. Then we have these dynamics carts that have these very low friction little narrow gauge wheels with a string attached that will go over a pulley with a weight, and there's a loop on the end of the string and a weight on a hook that's like this and weighs about 5 grams, plus additional weights like these. These weigh 20 grams each, okay? These can be put onto the hook, attached to the string, the weight falls, and that accelerates the cart down the track. Now, we need a way to measure the acceleration of the cart, and there's a number of ways to do that in a lab. You could use a motion sensor, you could measure distances and times maybe with a stopwatch, but the system that we've developed for this lab that seems to work the best is to use a photogate timer that is connected to the actual pulley that the string goes over. So this is known as a smart pulley, and this is a photogate timer. And the way this works is there's a beam of light that goes across here, across the photogate, and every time the beam of light gets broken, it senses that. And because this wheel has spokes, when the black part of the spoke breaks the beam, that turns it off, and then when the light comes through the hole, that turns it back on. And so the photogate timer basically gets turned on and off, on and off, on and off repeatedly as the cart accelerates down the track. And we'll be able to get a graph out of that using this device, which is called a Lab Pro. So this is this thing, okay, this is an interface that talks to pieces of equipment like the photogate sensor, and then it can read out data onto a graphing calculator that kind of clicks into it like so. And so you set this up punching a bunch of buttons, and then it will give you a graph, a velocity time graph of the cart as it moves, and I'll show you what that looks like after I do the first trial. So that's the setup. Okay, we've got a cart, a string, a pulley, weights falling, and then we just have to collect the data in a particular way. So one of the things about this lab is it's divided into two parts. There is the first part where we're keeping the total mass in the system the same and increasing, but moving masses around and increasing the mass on the string. So in trial one of part one, you have a total of 80 grams of these little 20-gram masses. 3 of them go onto the cart and 1 of them goes onto the hook. So I actually have 25 grams on the hook and 60 grams plus the cart here. And so if I move this weight out of the way that was holding it, and I would set this up and push start and let it go, it will look like this. Wow, that's so cool. So the weight falls, the cart accelerates. Now, you would reset this, but before I do that, I will show you what the graph looks like. So on a graphing calculator, you would get a graph of velocity and time that looks like this. And you'll notice that it's linear, and it's made up of a series of points of the velocity of the cart as it accelerated through. And you can scroll through this. You push this little arrow button, and you might be able to see how the x-axis and the y-axis change. The x-axis, of course, is time, and the y-axis is for velocity. And so what we will do is we will give you data for an initial time and an initial velocity and a final time and a final velocity, which you can then use to find the slope of this line, because the slope of a velocity time graph is the acceleration. So you'll be able to do a delta V over delta T or a rise over run and get the slope of that line, which is the acceleration. Okay, so that's what your data is going to look like. So that was trial one. Trial two, I want to show you all these trials so you maybe get a sense visually of what it actually looks like. So let me get some of these wires out of the way. We don't really need those now. And trial two is you move 20 grams from the cart onto the hook. So now I have 45 grams on the hook, and I let this go now like so. And you might have some idea of what it might look like, how it might be different. Here we go. Okay, that was trial 2. Trial 3, you move another 20 grams onto the hook. And I realize you can't really see the hook falling that great in this video setup. You can kind of get a little bit of a sense of it. But now I have 20 grams on the cart and 65 grams on the hook. And we'll let this go. Okay, maybe you notice a difference there. And of course, some of the weights fall off the hook. So we'll put those guys back on. And now for trial 4, we will put all of the masses, all 4 of the masses, so 85 grams now on the hook, and an empty cart. And we'll let this go. And that looks like so. And that's it for part 1. Okay, so the total mass in the system remained constant, but the mass on the string increased. And when we say the system, we mean the cart, hook, weights system, everything that's in motion that are all connected together because the hook and the cart are connected by the string. Okay, so that's part 1. In part 2, we're going to leave the mass on the string the same. It's going to be 25 grams the whole time, but we're going to increase the mass of the cart. So in trial 1 for part 2, or maybe trial 5, however you want to think of it, we have 25 grams on the hook and an empty cart. And that looks like this. Okay. In trial 2 of part 2, or trial 6, okay, I'm going to bring the pulley up, and now I'm going to add a 250 gram mass on top of the cart, this bar mass on top of the cart like so. So the mass on the hook is still 25 grams, but now I've increased the mass of the cart, basically doubled it because the carts are around 250 grams and this bar mass is also 250 grams. So I basically doubled the mass, and let's see what that looks like. Okay, maybe you can notice it looks a little different. The third trial of part 2, I'm going to add another 250 grams to the cart, and that looks like this. Okay. And finally, for trial 4 of part 2, I'm going to add a third 250 gram mass, so 750 additional grams on this cart, still only 25 grams on the hook, and let that go. And again, that looks quite different. All right, so that is the deal with the setup and how the data collection looks for this second law lab. You will be given, like I said, initial and final velocity and initial and final time data, which you can then use to calculate those accelerations and learn from this as you can. So again, it's too bad we can't be in the lab doing this all ourselves, but this is the best way we can figure out how to still learn these concepts. So hope that makes sense. We'll be talking about it in class. That's it. Hope it works. Have a great day.